I'll be showing you how to calculate the volume of non-rectangular and rectangular regions with the use of double integrals. Although it might seem like a very advanced application of what we know about integrals, we need to understand how to integrate double integrals first. The first thing you must do is identify the correct bounds, with each corresponding to its dx or dy. According to the Fubini theorem, it doesn't matter whether you do the integral in terms of x first or in terms of y first. What matters is that you have the correct bounds. Just like finding a partial derivative, when you integrate in terms of x, for example, you have to make sure that your y variable are constants. And make sure your bounds from a to b always correspond to x equations, and your c to d always corresponds to y equations. For rectangular regions, similar to the way we created sections of rectangles to find the areas of a region, we can use double integrals to find the volume under the surface z equals f of x and y over a region in the xy plane by finding the volumes of an infinite amount of rectangular prisms in the solid. Let the area of one of the rectangular prisms in the surface equal the change in x multiplied by the change in y. And let f of x of k and y of k be the height. Then the volume of one of these rectangular prisms is the f of x of k and y of k, delta A. As we learned with Riemann sums, if we take the limit of the sum of an infinite amount of rectangles, we actually get the area under the curve. If we take the limit of the sum of an infinite amount of volumes of these rectangular prisms, we will actually find the volume under a surface z equals f of x and y. So today I'll be showing you how to find the volume using double integrals for a rectangular region. So given that we're given the function x sine y, and we're trying to find the volume with our givens that x is between 1 to 3 and y is between 0 to pi over 2. We first want to set up our whole entire equation, our iterated integral, and make sure that your bounds are corresponding to the correct x dx or dy. So as you can see, the inner integral would be in terms of x from 1 to 3, which was from the bounds that we were given, and the outer integral dy is from 0 to pi over 2. And according to Fubini's theorem, as I told you before, it doesn't matter whether you do dy or dx first. So if we do want to integrate the inner integral with respect to y first, we always have to make sure that x is going to stay as a constant. And when we evaluate the outer integral, we keep y constant, but in this case there's no y's left. After computing, we find that the volume using the double integrals to find this rectangular region is going to equal 4. You can try to do this question on your own and then check with my answer. To calculate the volume of non-rectangular volumes, apply what you know about how to find the area between curves. Know which curve is the top or bottom when integrating a vertically simple region, and left or right when integrating a horizontally simple region. Note that drawing out a 2D version or XY plane is the only way you can correctly identify the components of your bounds for the double integral for sure. Don't try to imagine what the region looks like when you can just draw it out. For a vertically simple region, the top curve, or the g2 of x, will always be the upper bound, and g1 of x, or the bottom curve, will always be the lower bound of the inner integral. And the outer integral will have the bounds of the surface with respect to x, from a to b. You have to make sure the equations of the curves you are given are in terms of the correct variable, as you will be integrating with respect to y first, setting x as a constant, then integrating with respect to x. For a horizontally simple region, the h2 of y, or right curve, will always be the upper bound, and the h1 of y curve, or left curve, will always be the lower bound of the inner integral. And for the outer integral, you'll have the bounds of the surface with respect to y from c to d. You have to make sure the equations of the curves you are given are in terms of the correct variable, as you will be integrating with respect to x first, setting y as a constant, then integrating with respect to y. I'll be showing you how to calculate the volume of a non-rectangular region with double integrals. So given that our function is x minus 1, and with our givens, we find that x will be between 0 to 3 over the region between y equals x plus 6 and y equals x squared. First, what you want to do is identify the bounds correctly. So because this question is, you have to first identify the type of integration you want to use, vertically or horizontally. So the first thing you want to do is draw out the picture. So if you do draw out the picture, you'll see that y equals x plus 6 will be your top curve, and y equals x squared will be your bottom curve. From the picture, you could see that we'll be integrating vertically so that the top curve will not hit the bottom curve at all. To set up, you want to make sure that the inner integral is in terms of dy first, and your outer integral is in terms of your dx. And as you could see, the inner bounds are x squared, or our lower bound, because it's the bottom curve, and then the top curve will be our upper bound, which is x plus 6, and then our dx, which was from our given, is from 0 to 3. So you first want to make sure that when calculating that inner integral, that you keep x as a constant. And after solving and finding everything in terms of dy and plugging in the bounds, we get this. So now that everything is in terms of x, we don't even have to worry about y. We can just solve for the integral, plug in the bounds, and we get that our answer will be 27 over 12. So try to check with this answer after doing this question on your own again. The most hardest part about doing these questions is identifying the bounds, and the rest will be just algebraic issues if you do make mistakes. So really make sure that you draw a graph to see how to set up the problem. I hope my video was helpful in your understanding on how to calculate the volume with double integrals. Thanks for watching.